All right, so this is question number 9, January 2019. Question number 9. It says the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference. We're told that QRS is a straight line. Angle PVR is 75 degrees, and angle RTRS is equal to 60 degrees. So all that information we can see for ourselves. We're asked to determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. All right. So the first question, the first angle we're asked to find is angle PTR. We're asked to find angle PTR. So whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. So we're being asked to find angle T. So this angle is what we're asked to find. Ladies, gentlemen, this angle is 75 degrees. So angle PTR is equal to 75 degrees. And what is the reason? There are what? Angles in the same segment. All right, so I would have told students, you need to develop the ability to see the theory in the question. So for angles in the same segment, PR is a chord. So for angles in the same segment, both start at P and end at R, and both angles are formed at the circumference in the same segment. When you have an arrangement like this, the angles formed at the circumference in the same segment are equal. They are called angles in the same segment. So whenever you have a situation like this, the angles formed at the circumference in the same segment are equal. They are called angles in the same segment. So the angle at T is 75 degrees. So this angle here is 75 degrees. Next, we're asked to, so you're going to give you a reason for that. We need angle TPQ. Angle TPQ. We need this angle here. Angle TPQ. Now, guys, as I said, you need to be able to see the theory in the question. Angle TPQ. If this angle here is 60, this is also 60. This shape here is called a cyclic quadrilateral. And essentially, that is because all the vertices are touching the circumference. The 60 degrees is the exterior angle of the cyclic quadrilateral. And the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So this angle here is equal to 60 degrees. And it is 60 degrees because the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So this angle here is 60 degrees. The exterior angle of a cyclic quadrilateral is equal to the angle is equal to the opposite interior angle. Is equal to the opposite interior angle. All right. Next, we're asked to find the obtuse angle POR, where O is the center of the circle. We need to find the obtuse angle POR, where O is the center of the circle. All right, so this is 60. All right, so we don't know where the center is, but we're asked to find the center is O, and we're asked to find POR. POR. All right, so we're being asked to find this angle here. This angle here is 75 degrees. Guys, you see this angle is 150 degrees. And the basic reason for that is this. The angle at the center is 2 times the angle at the circumference. The angle at the circumference is what? 75. The angle at the center is 150. How do I identify angle at the center and angle at the circumference? They must both start and end at the same point on the circumference. They both start at P and they end at R. One goes up to the circumference, the other goes to the center. The angle at the center is 2 times the angle at the circumference. So I'm going to say that angle POR is equal to 2 times 75 is equal to 150 degrees. What is the reason? The angle at center is equal to 2 times the angle at circumference. All right. All right, now we're at the B part of the question. This looks like angles of elevation and depression. This says a person at the top of a lighthouse, TB, sees 2 ships, S1 and S2, approaching the coast as illustrated in the diagram below. The angles of depression are 12 and 20 degrees respectively. So the angle of depression here is 12 degrees. The angle of depression here is what? 20 degrees. This is the horizontal. This is the line of sight. So angle of depression is the angle between the horizontal and the line of sight when you're looking down. So the angle of depression to S2 is 12, that's the smaller angle. And the angle of depression to S1 is 20, that's the larger angle. Angle of depression is the angle between the horizontal and the line of sight when you're looking down. What else we're told? It says complete the diagram below by inserting the angles of depression and the distance between the 2 ships, which is 110 meters. So we do that and we get 1 mark. Then we're asked to determine to the nearest meter the distance T S2. We need to determine the distance T S2. Now to do that, more than likely we're going to have to apply TS2. All right. All right, so we need TS2. So we're going to have to look at this triangle here. We're going to have a look at the triangle in blue. So let me try and draw this triangle again. All right, I'm hoping that the software will recognize the shape and give me a triangle. Boy, no such luck, boy. This thing is just not nice to me at all. Third time is the charm. Is the software recognizing the triangle? No, it isn't. All right, so I'm gonna have to use this triangle here. I have one angle already. This angle here, it's not stated there, but you can easily see that this is 8 degrees. Now, from the horizontal to the first line is 12. From the horizontal to the second line is 20. So the angle between the two of them is 8 degrees. Now, this angle here is also 12 degrees. This angle here is 12 degrees. So this is 8 and this is 12, that's 20. It means that this angle here is 160 degrees. All right, so in order for it to not to be confusing, let me try and see if I can recreate this shape. All right, it recognizes it now. So I'm recreating the shape. Be patient. This is 8 degrees. This is 20 degrees, alternate angles, and this is 160 degrees. Sorry, this is not 20, this is 12, 160 degrees. This is 12. Down here is 110, and we're asked to find this length over here. Let's call it X. Now, this is a non-right angle triangle. And if you have a non-right angle triangle and you're given, well, here we have what? 3 angles and 1 side. There's a condition for applying the sine rule. Here's how the sine rule works. Since I want to find sides, it's X over the sine of the angle in front of X, which is what? The 160 degrees. And this is equal to 110 over the sine of the angle in front of 110, which is the 8. So it's the sine of 8. I'm sort of going to do a half cross multiply and bring this over here. We have X is equal to 110, the sine of 160 degrees over the sine of 8. So I just need to put this in my calculator and press equal. This is sine rule. So this is 110 sine 160 divided by the sine of 8 degrees. All right, and I have 270. And they said they want the answer to the nearest meter. So X, which is TS2, is that them asked me to find? Yes, is equal to 270. And the distance is meter. What else do they want me to find now? Next, they want the height of the light tower, which is TB. They want TB. That's the last thing they want. And they want TB. We need the height here. We just found this to be 270 meters. We have this angle here, which is what? 12 degrees. So I can use trig ratio, but using this triangle. So I'm going to use the large triangle to determine the height of the height TB. That's a large triangle. All right. I can't carry it to the next page. All right, but I know that the angle here is what is 12. And the hypotenuse is what is 270 meters. Over here is x. That's what I want to find, TB. Let's not call it x, let's call it y because we use x already. Y. This side is opposite to the 12, and the 270 is the hypotenuse. The trig ratio that includes opposite and hypotenuse is sine. So I'm going to say the sine of 12 degrees is equal to opposite y over hypotenuse 270. Ladies, gentlemen, if I have one fraction is equal to one fraction and I want to get rid of the fraction, I'm going to cross multiply. So 1 times y is equal to 270 times the sine of 12 degrees. So this is 270 sine 12. And the answer here is 56. 56. So this is y, which is TB, is 56 meters to the nearest meter.